All combinations pickup switching concepts, with sample diagrams. Warning: emotional and mental health hazard. This video contains technical information and material, presented with computer-generated speech and two-dimensional still images, which may be unpleasant, irritating, or harmful to persons with genetic or acquired personality or behavioral disorders or dysfunction. Affected persons are advised not to watch this video nor participate in the discussion. Do not proceed if you are not comfortable with any aspect of the presentation. Preliminary considerations and disclaimer. This video is my humble attempt to analyze and explain what I consider as the three basic approaches to arrange switches to connect the three single coil pickups in a Stratocaster guitar, in all possible combinations, with the end in view to provide a guide or procedure to design a fully functional system. The discussion shall be confined to connections involving three single coil pickups only. Sufficient level of knowledge and understanding of electronics circuits is required. Schematic diagrams are used to depict circuits, being a universal standard. Pictorial diagrams are provided only for illustration or simplification. Sound samples of the different pickup combinations are not provided, since they are presumed to be known to the viewer. For lack of a standard naming convention, I took the liberty of giving names that are descriptive to the three general schemes of connecting pickups. Customary parlance and definitions for the individual connection combinations will be adopted. Pickups shall be designated by their first letter, B for bridge pickup, M for middle pickup, and N for neck pickup. Connections shall also be referred to by the first letters of the connection and the number of pickups involved, P for single pickup connection, PP for two pickups in parallel, SS for two pickups in series, PPP for three pickups in parallel, SSS for three pickups in series, PPS for two pickups in parallel that are in series with one pickup, and SSP for two pickups in series that are in parallel with one pickup. In complex compound connection combinations, cited only in passing, mathematical symbols shall be used to describe the type of connections involved. Plus sign shall be used for parallel connections, minus sign for series connections, and grouped connections shall be in parenthesis or brackets. Single coil pickups shall be designated as P1, P2, P3, and so on. Humbucker pickup coil pairs shall be designated as H1A, and H1B, H2A, and H2B, and so on. Switch operations are treated interchangeably as discrete connection processes, and broadly as logic operations. Binary operation shall be understood as an operation of one of two operands, and the result is a state analogous to the operand. Switch positions are treated as logic gate inputs, and switch states on and off represents logic values true and false respectively. For purposes of simplicity and brevity, the phase switches are omitted in the circuit diagrams, but they are presumed to be included and connected, when all the possible combinations is being considered. The volume, tone controls, and the output jack are likewise omitted in the circuit diagrams, being collateral and inconsequential to the discussion. Only the essential explanatory and final circuit diagrams are shown. Minor, optional, superfluous, and collateral topics, illustrations and explanations, are omitted. Matters that are common knowledge or are notoriously known, those that can be easily inferred or derived from the discussions or illustrations, and those that involve numerous variations or iterations, are likewise omitted. This video is not intended to encourage modifying, or replacing the stock pickup switch of a guitar. Any modification made to a guitar may void warranties, invalidate rights in return and or refund policies or consumer protection policies, and or diminish the resale, historic, or sentimental value of the guitar. Exercise of sound discretion is advised. I am reserving my rights to all matters I have provided here. This video is presented strictly and purely as an academic discourse. No warranty whatsoever is made, on any part of the discussion, and in all illustrations and images. Use the instructions and diagrams at your own risk. I have no obligation to provide any kind or manner of technical support. Please exercise due diligence. By proceeding to view the remainder of this video, you are considered to have agreed and consented to all the foregoing terms and conditions. Point-to-point system. This is the basic foundation of all the switch systems discussed in this video. The essence of the point-to-point system is to individually connect or direct each pickup lead or wire to the other pickups or to any of the signal buses, using switches performing simple logic operations. Paths or tracks are laid out, and the switches turn the pickups on and off to the tracks or paths, to obtain the desired combination. The connection paths or tracks interconnect and form connection buses. We begin with the basic operation of one switch, with one pickup. The switch simply acts as an on-off switch for the pickup to connect or disconnect to the signal bus, a basic binary operation to enable or disable a component or device in a circuit. There are three ways to enable or disable a passive device in a circuit: by breaking the path to the leads, by shunting the leads, or by going around a lead. Essentially, that is to disconnect, short circuit, or bypass, each having its own inherent effect to the circuit. However, in a circuit where a disconnect operation is functioning properly, it does not follow that a bypass circuit or short circuit operation can also function properly, since they normally cannot substitute each other. In the sample diagrams, the bypass and short circuit switches will disable the entire circuit, and if there are other devices in the circuit, they will also be disabled. Any number of switches can operate on a single component or device, to perform different logic operations, as logic AND, or logic OR. Observe that in a bypass circuit, a two-throw or two-position switch is used, which is essentially two on-off or SPST switches, operating simultaneously but in an opposite manner. Adding a pickup to our setup will also require adding another switch position to the switches, to make both pickups connect in all possible combinations. A two-position switch, or an SPDT switch for each pickup will be initially used. Paths are laid out to connect the pickups individually, in parallel and in series, beginning with the most complicated. This is quite straightforward with only two pickups. The diagram may need to be rearranged or redrawn for clarity. Viewing both switches as component SPST switches, observe that half of both switches operate as a logic AND, for the series connection state to be true. In other words, two switches are needed to close, to connect the two pickups in series. However, only one connection operation is needed to connect the pickups across, to make a series connection, which will simplify switch operations. Observe that pickup 1 is disabled by disconnecting, and pickup 2 is disabled by short-circuiting. While both switch pair operations, 2 SPDTs and 1 SPST and 1 SPDT, will function properly, the first is a conditional operation and may be useful in simultaneous multiple operations, such as when there are 3 or more pickups involved in the operation. But aside from an electrical perspective, actual physical operation may also be taken into consideration. In this simple 2-pickup setup, using 2 identical SPDT switches might be a better option, in order to have an identical physical or tactile feel to the operation of the switches. Another option would be to use a 2-pole, 4-position rotary switch or slide switch. This switching system for 2 pickups may be useful in switching humbucker coils, combined with other switching schemes. Moving on to our final objective of switching 3 single coil pickups in a standard Stratocaster guitar, will require adding another position to the switches. With 3 pickups, the switching operations will have to be distributed to both ends of the pickups, considering that in an all-in series combination, one of the pickups will connect or float between the other 2 pickups, and none of its leads will connect to any of the signal or output buses. Thus, 6 SPDT switches will be used, one switch for each pickup lead, but treated as operating in pairs for each pickup. For the meantime, to simplify tasks, a way must be provided to turn off a pickup when a combination connection has less than 3 pickups. A separate switch for this purpose can be added, or just have it as an integrated function in the SPDT switches, as a center-off position. There are two approaches in conceptualizing the circuit diagram: 1, the ground-up approach, or building from the basic connections and progressing to the compound connections, and 2, the top-down approach, or forming the compound connections initially, then these are broken down to the simpler connections. Building from the basic connections is a logical and practical method in designing circuit diagrams, establishing the building blocks as the foundation of the whole circuit. The operation details are drawn sequentially one at a time, which gives a clearer perspective of the operation of the entire circuit, and it is less prone to errors. The procedure is easy, and it is the best approach for those who are not familiar with the processes or operations of the circuit. The concepts and processes discussed in the 1 pickup and 2 pickup setups are simply applied. But in order to have a comprehensive discussion, going through the process of building and modifying at the same time, I will use the second design approach in drawing the circuit diagram. The process of breaking down complex diagrams into component circuits is fundamental in revising circuits, either to correct errors, or to simplify, expand, or upgrade. The basic idea is to initially define the paths for 3 pickup combinations, and from there, the other combinations are derived. The simple combinations are merely components of the compound combinations, and they are defined in due course, as the compound combinations are defined and subsequently broken down. Take note that in breaking down to 2 pickups, there are only 2 types of 2 pickup combinations: 2 pickups in parallel and 2 pickups in series. The path for the 2 pickup series combinations, SS, and the all-in series combination, SSS, are determined first. The series connections are unique, in the sense that they cannot be broken down to make other combinations. In contrast, the all-in parallel combination, PPP, is a combination of independent connections, each connection being a complete circuit by itself, connected directly to the signal or output bus. After the series connections are defined, the compound connections for 3 pickup combinations, PPS and SSP, are determined from the paths defining the SS and SSS combinations, using switch logic operations. The definitive combinations are the SSS and PPS combinations, and they essentially make up the entire switch system operation. The PPS combination is built around 2 SS combinations, each terminating with a common pickup. If we disconnect one of the P in the PPS combination, the result is an SS combination, which solves the 2 pickup series combinations. If we reconnect the P, which we removed from the PPS combination, and connect it independently across the signal buses, we get an SSP combination. That leaves us with only the single pickup and 2 pickup parallel combinations to connect, which are components of the PPP combination, composed of the independent basic connections. The PPP combination is actually just connecting the pickups across the signal buses, and is by default, one of the 2 positions of the SPDT switches of each pickup lead. Thus, it may not be considered as part of the design process, inasmuch as it is necessarily inferred from its individual component connections, and vice versa. The SSP combination is only 2 pickups in series, with the other pickup connected independently across the signal buses. The SSP combinations also solves the 2 pickup series combinations, as pointed out earlier. With these constraints and parameters in mind, we now have a complete picture of the switch operations, and we can now easily proceed with designing the actual circuit diagram. Bear in mind that these are also the universal fundamental operational conditions for all types of all combinations switch systems. In setups with more than 3 pickups, the process is the same, but additional operation conditions are added into the formula. I decided to initially use logic N, operations for all the series connections of the 3 pickups, following the same logic operation of the 2 pickup series connection example earlier discussed. This is a purely arbitrary choice and any connection pattern will suffice, as long as all the series connections are defined, that is, the series connections for 2 pickups, and the series connections for 3 pickups. Thereafter, the paths to make 2 pickups in parallel that are in series to the other, PPS, are defined by placing paths and junctions on the paths for the series connections. Eventually, a rudimentary circuit diagram is produced, which will be our base circuit. Observe that the series connections, and the parallel to series connections, share a common internal bus. To test the logic operations of the base circuit, permutations of all the switches are traced and tabulated in a truth table. To abbreviate this procedure, we only need to trace the connections that are of interest, that is, the 17 parallel, series, and compound connection combinations. Going directly to the result of the initial tests of the 17 connections, the base circuit fails to make an all-in-series combination, or an SSS combination, because of the junctions placed on the series paths to make parallel connections. This error is made obvious by the fact that the path for the series connections, and the path for the parallel to series connections, as we have noted, are shared in one bus. Applying the operational conditions for 3 pickups, there are several solutions we can attempt to remedy the error. Remove S1 from the junction on the parallel to series path, by making switch S1 a simple binary operation to connect the neck pickup to the middle pickup in series, and this will also make S1 and S4 operate as a logic AND, for the same lead of the neck pickup to connect to the internal bus in the circuit. Or, remove S3 from the junction on the parallel to series path, by making S3 a binary operation to connect the middle pickup to the bridge pickup in series, and make S3 and S6 function as a logic AND, for the same lead of the middle pickup to connect to the bus. Or both solutions may be applied simultaneously to our base circuit. Or, continue with the apparent solution postulate, that is, to make a series connection state true, the state of only one switch needs to be true. Thus, we can also try to remove S6 from the junction on the parallel to series path, by making S6 a binary operation to connect the bridge pickup to the middle pickup in series, and make S3 and S6 function as a logic AND, for the same lead of the bridge pickup to connect to the bus. After verifying and testing all our solution options, the result is that all the circuits derived from our corrections, work, and function as drawn, as switch systems that can connect the 3 pickups in 17 unique parallel, series, and compound pickup connection combinations. It must be pointed out that this set of solution procedures applies only to this particular base circuit design, and it is not a universal solution for all designs. However, the principles behind these correction solutions are applicable in simplifying or expanding the circuit. This gives us several circuit diagrams to choose from, as a possible construction project. Adding phase switches to 2 of the pickups will make our circuit connect all the pickups in all 47 different possible connection combinations. Optionally, redundant paths and operations may be removed from the circuit. Observe that there are now 2 internal buses that were created in our circuits. The buses function either, 1. To connect 2 pickups in parallel which in turn allow the pair to connect in series to another pickup, or 2. Establish a series path between 2 pickups, and for 3 pickups. This feature of buses will be further exploited in another switch system, which will be discussed later. From a user perspective, 6 switches can be quite intimidating to operate. Therefore, the switches must be laid out to make their operation intuitive, or at least semi-intuitive. The parallel connections can be uniformly configured in one identical position of the switches, for example in the up position. The adjacent switches of adjacent pickups, the middle and the neck, and the middle and the bridge, may be configured in such a way that their down positions will connect the adjacent pickups in series, when the other switches of that adjacent pickups are in the up position. These are merely suggestions, and the final layout depends on user preferences. There are also a lot of redundant and dead sound combinations. Thus, it is strongly recommended that a copy of the truth table, or relevant portions of it, or a copy of the circuit diagram, should always accompany the guitar, as ready reference to verify connections. However, with regular use, familiarity with favorite combinations will be acquired. The biggest advantage of this system is its low cost, availability of parts, and the ease of construction. Despite the number of switches, assembly is very easy, and employing a point-to-point floating wire construction, also known as spaghetti wiring, will suffice. The switches are available in different profiles, and the entire switch system with phase switches can fit in the switch cavity of the guitar, if sub-miniature toggle switches are used. Since the switches used are usually sealed toggle switches, this system is quite robust. This system also easily lends itself as a good basis for a digital design, since the switch operations are essentially binary. The concepts used in the point-to-point system are also applicable in designing the other switch systems. They are also useful in simplifying the circuits, or when expanding them to accommodate humbucker pickups in HSS, HSH, and HHH setups, treating each humbucker as two single coil pickups, to connect all of the coils in complex compound connections. Template system. This system is built around two circuit blocks that selects and combines predefined patterns and sequences, based on the concepts that, 1. There are only 7 basic patterns by which the 3 pickups of a Stratocaster guitar can be connected, and, 2. The pickups can be arranged in only 3 electrically unique sequences. The first circuit block defines the basic patterns, which are constructed as templates, and is initially built around a 7-position switch with 4 poles, 4P7T. The 7 basic patterns are, 1 pickup, P, 2 pickups in parallel, PP, 2 pickups in series, SS, 3 pickups in parallel, PPP, 3 pickups in series, SSS, 2 pickups in parallel that are in series with 1 pickup, PPS, and 2 pickups in series that are in parallel with 1 pickup, SSP. The pickups are then positioned in a sequence in the selected pattern or template, that will connect the desired combination, which is the function of the second circuit block. The possible position order or sequence of the pickups are 6. But considering that the direction or order of the sequence is irrelevant, there are only 3 electrically unique sequences. For our circuit design, I decided to use the following sequences: BMN, the default, MNB, and NBM. A combination of the reverse of the mentioned sequences, NMB, BNM, and MBN, will also work. This will require a 3-position switch with 6 poles, with 1 pole assigned for each of the pickup leads, 6P3T. Switch operations of the basic circuit diagram, as shown, are self-explanatory. The arrangement of the switch positions can be changed according to user needs and preferences. To operate the system, the connection pattern is first determined by the template switch, then the pickups are positioned in the template by the position switch, according to the desired combination. For example, let us assume that we want to connect the bridge B and neck N pickups in series, SS. First, we select the pickup pattern switch to SS, which may be configured as SSX, SXS, or XSS, depending on the design of the template selector, X being equivalent to no pickup connection. Assuming that the template selector is designed with an SSX configuration, as shown in the circuit diagram, the pickup position switch is then set to NBM. The bridge B and neck N pickups are thus connected in series. The switching methodology is unconventional, but it is not difficult to become accustomed to its peculiarity. The main attraction of this system is that it uses only 2 switches to accomplish all the pickup combinations. There are also no dead sound connections, and redundant connections are kept to a minimum. The main drawback is that the switches are quite difficult to find. The 4P7T and 6P3T are large profile switches, which makes them a challenge to layout, and switching between the different positions may also require some dexterity. In exchange for some redundancy and dead sound combinations, the template selector can be limited to selected patterns, but the phase switches must have a center-off position. The cost to build it is reasonably flexible, and depending on the type and quality of the switches to be used, this system can be quite cheap, or very expensive to build. Bus system. This system uses different buses, or paths, or tracks, to make different pickup combinations. Each pickup has a dedicated switch module to connect logically to any of the buses, and each bus performs a particular type of operation or connection. For example, a parallel bus is used to connect a pickup in parallel to other pickups, a series bus connects the pickups in series, a parallel to series bus connects two pickups in parallel, which has a provision to connect in series with another pickup, and a series to parallel bus connects two pickups in series, which has a provision to connect in parallel with another pickup. Technically, the series bus may not be considered as a bus, since by its very nature, the path is broken by each device connected to the bus. But for uniformity and clarity, since the path is a common signal carrier for the series connection, it will be considered as a bus, whether it is a continuous path, or a broken path. To keep it manageable, the buses must be kept simple and as few as possible. One method to limit the number of buses is to use a control switch, to bridge different buses to get the desired combination, from parallel to series, or series to parallel. On the other hand, to dispense with the control switch in an existing design, the bus, or buses displaced by the control switch must be re-established. The decision to use a control switch is better left to the discretion of the user. But as the number of pickups increases and the connection combinations also increases, it becomes very practical to use a control switch, in order to simplify operations and also reduce cost, since large array switches are difficult to find and are quite expensive. In the circuit diagrams, I decided to use an expanded rendering of the 4 PDT switches, and the 3 PDT switch, into individual component SPST switches, to make it easier to follow the paths and switch operations. The switch schematic diagram used is actually a representation of a slide switch, or a rotary switch. The pickup switches perform only simple binary operations, connecting or disconnecting pickup leads to the buses. The circuit buses are labeled for convenience, and a simple trace will reveal how they function. Pickup switches, S1, S2, and S3, selects the connection mode of the pickups, parallel, off, or series. Component switches function in pairs, A and C, are responsible for the parallel connections, while B and D are used for the series connections. In parallel mode, the pickups are turned off by disconnecting the leads. In series mode, the pickups are turned off by bypassing the leads. The control switch determines which connection bus takes precedence to the output, and it also determines whether the series bus will connect to the output for SSP combinations, or to the parallel bus for PPS combinations. The SSP and or PPS buses will have to be recreated if the control switch is dispensed with. There is nothing critical in the design, and everything can be modified, as long as the basic structure is maintained. The bus system is a symmetric modular circuit, which makes it very easy to implement any modification to the circuit. There is quite a number of redundant and dead sound combinations, but the operation of the switches is intuitive. The circuit diagrams are primarily designed for 3 pickup configurations. The control switch can be replaced with a DP/DT switch, but guitar setups with more than 3 pickups, with additional buses for complex compound connections, the wiring concept of the 3 PDT, as shown, may be adopted, and expanded as necessary. Unlike the other previous switching systems, the bus system is very easy to upgrade and expand to accommodate HSS, HSH, or HHH pickup configurations, connecting each coil individually, since all the components are modular. The pickup switches connect and operate identically. But the simple addition of a switch wired identically as the existing switches, when adding another pickup, will not be able to connect all the pickups in all the new combinations made possible by the addition of a new pickup. As an alternative, a separate point-to-point switching system may be used for the humbuckers, but this will also fall short of being able to connect all the possible connection combinations for all the pickups. Complex compound combinations will require adding new buses entailing larger switches. In any event, this basic bus system for 3 pickups is very intuitive to operate, and a guitarist unfamiliar with it will easily learn how to operate it, provided it is properly labeled. All the switches operate in a uniform manner. Its disadvantage is that it is quite difficult to build. As designed in the circuit diagram, this system requires 3 4PDT on-on-on toggle switches, which are quite difficult to find, usually available only online, and they are also quite expensive, and 1 4PDT toggle switch is usually more expensive than a respectable second-hand guitar. However, to bring down dream-level aspirations to tangible-level realities, for low-budget applications, properly wired 4P3T slide switches, or rotary switches, can be used, instead of the 4PDT on-on-on toggle switches. Or, dispensing with the control switch, 3P4T rotary switches, or 4P4T slide switches can be used. When substituting 4P3T for the 4PDT on-on-on switches, switch position layout will be flexible, and can be customized to make it possible for transitions between certain favorite combinations, require moving only one notch of one switch. This makes an excellent all-around switch system, whether for a studio guitar, or a live guitar. Considering the alternatives, this system can be reasonably cheap, or very expensive to build. Good practices. It cannot be overemphasized that good layout and construction techniques are necessary in building good working devices. Additional measures, such as sufficient shielding and proper grounding, are also essential. It is always a good idea to plan ahead, and make actual physical measurements of the devices and the available space, before commencing construction. Bad implementation of a good plan is like executing a bad idea. Deciding the design. Choosing the right switch system depends on the circumstances of the guitarist and his guitar. Spending more than $70 on switches for a $10 second-hand guitar may not be reasonable. On the other hand, installing a $5 switch system in a $2,000 guitar may not sit well with the social class or status of the instrument, which distinction exists only in the minds of owners of such instruments. But the most expensive system may not necessarily be the best. In fact, a simplified version of the point-to-point switch system has a less number of switch position permutations than the bus switch system. But the bus switch system is more intuitive to use than the point-to-point system. The template system is the most efficient system, but switching between 7 switch positions is a physical and mental challenge. For some, the advantages of a particular system may outweigh its disadvantages, while for others, it may be the other way around. The switch systems presented here are only the basic circuits, and they serve mainly as guides for educational and research purposes. There are different approaches to the different schemes, and the processes can also be combined. Although the circuit diagrams shown here are fully functional, and should work as drawn, they can still be modified and improved for practical considerations, to make them more efficient, intuitive to operate, easier to construct, reduce cost, and all other improvements to make them generally function better for the user. The decision to modify depends largely on user preferences. The concepts of switching systems explained in this video is comprehensive enough to equip the viewer with more than sufficient knowledge and information to undertake the task of designing or modifying a switch system. Everyone is encouraged to explore beyond what has been presented. Do not blindly conform, but analytically explore. Most of the time, the journey is more important, meaningful, and memorable than the destination. In the final analysis, processes are more valuable than the result or the product. But having said all that, it must also be pointed out that there is nothing wrong with copying and adopting circuit diagrams offered for free for personal use, or are available in the public domain. The circuit diagrams presented here may also be used. Even though I have thoroughly checked and verified the circuit diagrams as well as the accompanying text narration, explanation or description, that does not relieve you from exercising due diligence by checking and verifying the circuit diagrams yourself. Always be an independent thinker rather than a mindless follower, or a vacuous critique. I hope that this presentation provided insights in choosing and designing a switch system that will meet your requirements. That concludes this presentation. Thank you for watching. Please confine discussion topics in the comments section, to all combinations switch systems only. Your valuable insights will be appreciated.